Hello, welcome to this short tutorial on S-PHOT, an app created through the EU-funded project Explore. In this video, we will highlight how to use this application and the scientific data that can be produced with it. S-PHOT is one of 6 scientific data applications that can be found on the Explore platform. For more detailed information on its features, you can always consult the corresponding user manual. S-PHOT is designed to reproduce the fundamental properties of astronomical objects from multi-wavelength observations. The driving tools behind S-PHOT are the S-PHOT libraries. These libraries retrieve photometric data from across a wide range of wavelengths from online databases. These photometric data can be combined with other types of data gathered on the target, including distance and interstellar reddening information, to recreate the object's emitted spectral energy distribution. The user can fit this spectral energy distribution with either a black body or a stellar model atmosphere to reveal properties of the astronomical source, such as its temperature and luminosity, and to search for an excess or deficiency of flux at specific wavelengths. An offline version of the S-PHOT libraries is provided, designed for users that require a long list of targets, area searches, or the ability to include offline datasets. When opening the application, the user is presented with 3 choices. First, an empty user interface. Second, a demonstrator of the machine learning stellar classifier. Or third, a demonstrator of the default user interface. Choosing an empty UI results in an empty visualizer panel, in which the user can create their own visualizations. A target or target list can be input using one or more identifiers. These can be coordinates or astronomical objects resolvable by Simbad. The default UI automatically opens several visualizations for demonstration targets instead. After selecting the preferred UI and inputting the desired target or list of targets, the visualizer is opened. On the left-hand side, different data selections can be made. With the selected data, a visualization type can be chosen with the viz picker on the right. After selecting a visualization type, it appears in the central workspace. Some machine learning options are presented in the Algo Picker panel. Different datasets can be opened or closed by using the drop-down menu in the top left corner. The header provides several additional options to the user, such as adding annotations or sharing the dashboard. There are many different visualization combinations possible within the S-PHOT toolbox. This tutorial will therefore only address the content of the visualizations that are presented when opening the default UI option. However, feel free to explore the many other options in the UI. Hovering over the buttons in the Viz and Algo Picker panels allows you to view more information on the visualization type and the requirements for data selection. Many provide suggestions for generating common plots. After selecting the default UI option, 5 data windows are opened. In the top left, a Hertzsprung-Russell diagram is presented, which plots the luminosity against the stellar temperature. The SED graph to the right of the Hertzsprung-Russell diagram shows the object's spectral energy distribution in Janskys at different wavelengths. The points used in the fit are coloured, while points not used in the fit are in grey. The best fitting model is shown as purple points connected by a purple line. In the top right, a plugin of the Latin sky map is shown, which displays the object's location on a map. The bottom 2 windows show different tables. The table on the left shows a catalogue of the photometric observations that are used, and some corresponding data measured in the observation. The table on the right shows non-photometric observations associated with the target, such as the object's proper motion and coordinates. The default S-PHOT user interface allows the user to interact with the displayed data in several ways. For example, control-clicking on an object in the Hertzsprung-Russell diagram will select the object and display its corresponding spectral energy distribution in the graph and table. A selection can also be made by drawing a selection box over the data point. Additional information on data points can be found by hovering the mouse over the point. The individual data windows can be downloaded by the user using the download option in the top left corner of the window. Furthermore, the full dashboard, including potential annotations, can be shared with other users by clicking on the Share Dashboard option in the top header.